Hi, welcome to Design Strong. So today in this video we'll see how to design a Twitter. So basically Twitter is a very large scale system with order of 1.5 billion users who have created their profiles and around 400 to 500 million monthly active users on their system. Twitter as a platform is very important because generally the first source of information for any news which is happening is Twitter. So this is an important system in design interview question as well, and we need to ensure that we understand the basics of how a large scale system such as Twitter works. Plus there are some important concepts which will be interlinked. For example, there can be a URL shortener, etc. So don't miss out on this video. This can also be used for designing any sort of news feed as well. So I hope you like it, and guys, watch the full video because every aspect of it is important from the perspective of a high level design in a system design interview, because Twitter as a system is very large and it is almost impossible to design complete system in, let's say, a 40 or 50 minutes or even a 1 hour interview. So we need to understand what are the points that we need to focus upon and what are those points on which the interviewer as well will be interested to knowing.
2 hours later.
Hi, so in this video today we will see how to design a Twitter system, or rather how does a Twitter system design question needs to be answered in a high level design interview. So let's get started. Okay, so in Twitter system design interview we need to start with functional requirements. We need to understand what is the system intended towards in terms of functionality. For example, a simple Twitter system will have three functionalities, which is send a tweet. A tweet is nothing but a message of 140 to 160 characters. Ability or functionality to do a retweet. That means a tweet which has been done by one of the users, you can retweet it. Or a follow system wherein user can follow multiple users, and then in turn there can be a graph of following between different users. In terms of non-functional requirements, we need to ensure that the system has fast rendering. The system of course will be read heavy because let's say in case if you are sending a tweet, in turn you'll be reading out at least 100 of tweets for other users whom you're following in general. Plus in case of like big personalities such as CEOs, CXOs, actors, sportsmen, etc., their tweets are generally read by more than million users at times. So we need to understand that this is more of a read heavy system that we are designing here. Third is a fast tweet. Fast tweet would mean that a tweet which has been sent should get circulated fast enough, because let's say if there is a news that is being tweeted by one of the news handles, then if in case it gets delayed, then there is no point in having a system which has a delay. And fourth is because we need to understand that every system can have some sort of exceptions that needs to be there. So in this case, lag to an extent is acceptable. Lag in the sense that, let's say if I am doing a tweet and you do not see it for 5 seconds, this is fine. But let's say if I am doing a tweet and you are not seeing for let's say another minute or so, then this is something which will not be acceptable for a system like Twitter. On the scales, I'm not sure if you're aware, but Twitter has around 180 million daily active users right now, and around 400 million users who are active on monthly basis, and overall they're serving over 1.5 billion total number of accounts, and whoopingly they are having 500 million tweets per day. When we divide this for getting an average of per second, this comes at around 5,500 tweets per second. And at times when there will be peaks, at times when there will be situations such as COVID, etc., then like these can peak up to even 50,000 tweets per second. Next, for creating a system which is simple enough, we will first need to understand the segregation of users. So right now for this system design, I have decided that users will be divided into 5 segments, and the segments being: 1, inactive users. So inactive users are the users who have not logged in to Twitter, let's say for over a month. Passive users are someone who seldom logs into Twitter. Let's say they have logged in between 15 days to 30 days. Then there are live users. Live users means the users who are currently accessing the system. Active users means anybody who has access to Twitter system in less than 3 days. And famous users are the users who, let's say, have more than 1 million followers. Why we are doing this user classification? You'll get an idea when we do the design for this. Now, in case if you have a question regarding this user classification, because this is a bit debatable, but then for the current design that we are doing, this should be fine. Now let's move on to the actual design, which happens for 3 functionalities, which is when user posts a tweet, when user checks their own timeline or somebody else's timeline. We call it user timeline. User timeline means all the tweets on that page will belong to the specific user. Then there is a concept of homepage feed. So in homepage feed, what happens is the tweets for all the users whom you are following will be visible in order of time or in order of popularity. The default sorting is popularity, but we can change it from the timeline to be on the on the basis of created ad as well. So this is how we are going to decide for the 3 functionalities how the system will be designed. First, what we have done is we have created a BFF layer. In case if you're not aware what is BFF, I have also explained it in our previous video for WhatsApp. This is backend for front-end layer. Basically in large scale systems we'll have BFF layer. Not a lot of designs will explain this, but a BFF layer is very important because several aspects such as load balancer, authentication and WebSockets etc., which are for direct connectivity between the app or the actual user, can be handled at this single layer. Advantages, let's say if we are authorizing and authenticating at the BFF layer, we need not have those header based authentication everywhere into the internal system. So this would mean that BFF also acts as the security layer. So on BFF what we have are load balancers, which will be responsible for routing the load which is there, and authentication authorization service, which will be responsible for authenticating whether a user is authenticated or not, whether the user is logged in or not and whatnot. And WebSockets will be for enabling notifications for the live users. Now the first service that we need to understand in this design is an ingestion service. Ingestion service comes into picture as and when user posts a tweet. So user sends a tweet, it goes to BFF layer and then it goes to ingestion service. Now first job for this ingestion service will be to persist this. They are going to persist this in, let's say, a database, and this database has to be it should be able to support a large data, because the number of tweets which are coming in per second is increasing ever. So here we have decided that we are going to utilize something like a Cassandra cluster, because this is a NoSQL database, and for this kind of requirement we have Cassandra scales very well, and it has no problem in scaling up to terabytes and petabytes as well. So from that perspective we have created Cassandra, and to avoid single point of failure, what we are doing is we are creating a cluster. In case if you're not aware about cluster, I would strongly suggest that we should look out for resources which explains cluster. Cluster is nothing but it's like horizontal state scaling. So we'll have a cluster of Cassandra which will be responsible for providing that response. So ingestion service sends that details to Cassandra service, and then at the same time this ingestion service is also writing into a topic into a Kafka queue. Now why we are doing this Kafka queue, we'll come back to this later. What happens from Cassandra is this information will flow into tweet service. Now one more thing to keep in mind here is that this ingestion service will also have a media service. So what this media service will be responsible for is, in case if the user is tweeting, let's say, an image or video etc., then this will directly go into media service, and then media service will be persisting it into, let's say, an Amazon S3 sort of bucket. Plus media service can also act as a URL shortener. So URL shortener is because Twitter has this limitation of having only 140 to 160 characters in a tweet. We do not want that a lot of this length is taken up by a URL which is being shared by the user. So what we will do is we'll have an internal URL shortener as well. In case if you're not aware about what is a URL shortener, I have done a video previously on this as well. So media service is nothing but applicable for doing all the media storage etc., and then returns the ID, which then again flows into Cassandra. These operations can happen in asynchronous mode, so that both the operations, there is no lag in between and it gets happened in a quick point in time. Then there is a tweet service which is connected to Cassandra. As and when there is a tweet which was persisted into Cassandra, tweet service will come into picture. And what does this tweet service will do is, tweet service will be responsible for sending out this tweet wherever it is needed. So tweet service will inform timeline service that the user this have posted a new tweet. Now timeline service is connected to a Redis, and there is one more tweet processor. So as and when a tweet is there in the Kafka queue, tweet processor will look for incoming signals from the Kafka topic, and as and when they find a new tweet in the Kafka, what it will do is it will process that tweet. It will find out what are all the users who are connected to this user, because let's say if there is user A being followed by B, then if user A sends a tweet, it should be visible on user B's timeline as well. So user service here will tell us that information via timeline service, and timeline service will be connected to tweet processor, and then both of them together will create a timeline for the user and put that into Redis. This is like we are calculating a timeline in advance, because let's say if I am going online on this, then I don't want that this timeline calculation happens then and there, because there will be let's say if it is taking 10 seconds, we do not want to show that user lag. So let's say for active users that we created and the live users that we segmented, we will have this timelines calculated already based on the tweets which are there. So this information will be available in Redis, and Redis will post that out to timeline service, which will then flow into user. Now for user timeline also, the timeline service will come into picture. They'll know that this is for a specific user. They'll fetch all the tweets from the tweet processor, and most probably this will be available in Redis. In case if the user is not into the live or active segment or a popular user, that means a user who was earlier an inactive user etc., then this information will come from the tweet processor getting it via Cassandra. So this is one sort of an architecture. What is interesting here is this graph service. So graph service is important because graph service is going to have this information of which user is connected to what all users, and this service is basically named as graph service because it's more like a graph. A user can be followed by multiple users and vice versa, and it's like many to many connection which we have here. So after this, next we will see how does the other three processes that we need to discuss, which is user onboarding and login. A user follows a different user, and how does the behavior of user app or website looks. So in case of user onboarding, what will happen is user service will be responsible, or user service will be responsible for handling that action, whether this is creation of new user, updation of existing, or let's say user is trying to delete their profile. And user service will be connected to an RDBMS. Aurora on MySQL is something which works well here. Why we are choosing Aurora here? Because the write IOPS and the read IOPS here are unlimited on RDBMS, which are based on Amazon Aurora. This user service will also have a Kafka queue which is connected, because this information of creation, addition and updation of users will also be required for other services such as timeline service and user notification services, because they need to know which user is online or which user has deactivated their profile, because we do not want to serve the tweets from a deactivated profile to anyone else. User service will also be connected to a Redis which we have created here, and basically this Redis will be responsible for storing profile information in a key value pair for users who are into, let's say, live, active or popular segment, because we want to serve this user profile section in a faster time. Plus, not often you will see that a profile is being updated. It's like if we compare sending or reading a tweet to updating a profile, it will be 1,000:1 sort of an operation. Again, we'll have a graph service which will be utilized for user follow operation. So graph service basically will be responsible for creating a graph between the users, like who are their followers and whom they are following. So this is graph service. And graph service will have their own graph DB cluster, which again will be an RDBMS, because we'll have a different sort of relations between this data. So right now MySQL is what Twitter is using. So what we are suggesting here is RDBMS, again Aurora based on MySQL, so that the IOPS operations are unlimited. And of course there can be an analytics service which does the operations such as see what is the trending and what are those hashtags, etc. And of course there will be a user notification WebSocket service which will be taking those tweets from the Kafka and sending them back to the user app. Or a user notification service can also be used for sending out a notification to everyone whenever a user, let's say, is live and this user is in a popular category. This can also serve that use case. So this in simple is the Twitter design. What we have discussed here is user onboarding and login, user follow, user app and web, and the three basic operations that Twitter supports, which is post a tweet, user's timeline, which can be your own timeline or anybody else's user profile timeline, or a home page feed which contains tweets from all the users. And the basic thing that we need to keep in mind is in order to scale and in order to serve that sort of scale, we need to have auto calculated timelines so that the design is simple and works very well. So guys, I hope you like it. This was basic Twitter system design that we wanted to perform on Design Strong live on YouTube. Thank you and say. So guys, that was it from Twitter design for the system design interview series. I hope you like it.